So hey guys, Andrew here. Welcome to my new YouTube channel. So we are here. I'm here to probably give you a view of my problem I've discovered and how I will use AI to solve it. Now, my problem that I've discovered is that in Uganda, the number of cars are increasing, and this has led to increasing traffic, loads and loads of traffic, like on roads, there are heavy traffics, people leading to delays, people going to work. Now, my observation is that even ambulances that take patients to hospitals are delayed in traffic, and this has greatly affected the health sector because these patients that in ambulances and of which these ambulances are delayed in traffic, it has led to deaths of very many patients due to delays of ambulances in traffic. So, what I probably want to do, especially in this country, is to solve that problem of ambulances being delayed in the traffic, so that they can be able to take victims in the hospital in time. So, using AI to solve this problem, what I've thought about is that, like, as you can see, traffic lights on roads are trying to minimize traffic on the road. And in this very same way, what I can do is introduction of cameras onto the roads that can be able to identify and verify ambulances in the traffic, and also be able to connect to the traffic lights in some way in order to only allow ambulances to pass through the traffic in order to prevent delays, because following the SDGs that were introduced by the UN in 2017, the uh, connected to the health sector, the Sustainable Development Goals introduced by the UN. Following the health sector, this can be a huge impact that can boost up the health sector, because if this project is to work out, the health sector will have improved, because this is a major problem that is affecting the health sector. Now, what the data I'm going to use for this project is basically image data, because the cameras will capture images of vehicles probably. So of all those images that are vehicles, I will use AI to identify the ambulances and verify them, and also at the same time give them access to the road freely in order not to wait in the heavy traffic. And now, the modes of learning. I can either use supervised learning or the unsupervised learning. Now, if I'm to go to the side of supervised learning, okay, they are different and they are opposites. Now, for the supervised learning here, label datasets are used. Now, it is the writer, that is me, that is like making the AI project that labels the dataset, that this is my dataset of vehicles. And for the unsupervised side, it is not me, the writer, that labels the dataset. The dataset that is used is unlabeled, meaning that it is the AI that labels that categorizes the dataset to be used. Now, another thing for supervised learning is that it executes less complex processing tasks. Now, for this task of maybe identifying ambulances, it is not that complex, whereby you just have to identify the images. But for unsupervised learning, here more complex processing tasks can be executed. Now, for example, if I am to choose that instead of images, I'll take the sound. So there are many sounds an ambulance makes, and also there are many vehicles that make the same sound as an ambulance. For example, police cars. So to require complex processing in order to screen out the sound made by an ambulance. So that's what supervised learning can do. Then another thing for supervised learning is that it minimizes errors in a model because cross-validating is done with the training set. No, so I have a training set of data like that I can work with in order to verify that it's an ambulance lab is a training set I can use. But on the other side of unsupervised learning, there is no training set I can use. I just have to work on the data have received that moment. So it will require a lot of deep learning there because there is no cross validating. So another thing, another thing is probably talking about the techniques. Now, if I am to choose the side of supervised learning, if I'm to choose the side of supervised learning, I'll probably the techniques that are there are I'll probably choose linear regression because in linear regression, this is a technique that's basically that is typically used to predict and find out the relationships between the data. Now I have data here. I have two data sets. I have the training data set and the data I have to use. So it will be easier here because I have to identify the relationships between those data sets, like the images, the relationships between those images, like are they of the same size, are they of the same shape, are they of the same maybe color. So that's how linear regression does it, and in that way I can easily identify the size of an ambulance, maybe the shape of an ambulance. So that's linear regression. Maybe another technique in supervised learning is classification. And this classification is a technique that basically analyzes data and recognizes the patterns between those data sets. And now, for example, I have my training data set that I may have got through crowdsourcing. So what I do here, I classify the data like maybe according to size, according to shape, because ambulances may have various sizes and shapes. So not to be left behind, I classify the data in terms of size, shape, maybe color, in order to see if there I can get an ambulance from there because there are small ambulances, there are big ambulances. So in order to do that, classification can help me. Maybe another, okay, probably two I will go with. So for the if I'm to opt to choose the side of unsupervised learning, the techniques I would probably go with clustering. And clustering, there are very many types of clustering. But now, if I am choose, for example, let me hint out on one, the K-means clustering. So this cluster, okay, it's basically about calculation. And this technique an unable data set, it is arranged into several clusters that have to be of the same size, first of all, point that. And another thing, their number, the number of clusters created by the system has to be noted. Then if I have a given number of clusters there, I can be able to get all the data points that are sent to the nearest centroid. Then the variance is calculated. And then the new centroid for each cluster is put. Then assigning the data points is done. Then the best, then the what? Then the latest cluster processed to the centroid is determined. But if that is successful, the model will be ready. So can either go for the K-means clustering, though it's not suitable for all projects, and I don't think it can be suitable for my project. Then another technique is the anomaly detection. Now, in this technique, as you can hear, anomaly, like detecting anomalies in a data set. Now, for example, I have a data set has images of vehicles. Vehicles, okay, they may be of different sizes and shapes, but they should not, okay, they should not again deviate too much. Like for example, I may capture an image of a three-wheeled vehicle or maybe a tuk-tuk. That that is abnormal. That is irregularity of my data set. So I have to screen it out to remove all the anomalies. Maybe in taking images of vehicles, I took an image of a border or something that is not even connected to an ambulance. So in that, I can be able to screen out the uncertainties in my data so that I can be able to work with the more similar elements in my data set. Then the challenges I'm likely to face in my AI project. The biggest challenge I'm likely to face is the bias problem because in a bias problem here it comes around when I'm working on a very small data set, and the functionality of the AI system depends on the quality or the amount of data that is trained on. Now, for example, I may opt for crowdsourcing to get data, and people may give me, poor quality data. People giving me images of vehicles that are not ambulances, that are resembling ambulances, that are even not ambulances at all. So even if even if I have a large data set, but when it is poor quality, that will lower the quality of my AI system because it has poor data. Or it may be good quality data, but when it is small in size, when it is limited, that will also affect the functionality of my AI system. And that's where the bias problem comes about. Then another problem is the human level. So in a human level, AI is designed to perform human-like tasks, and yeah, true, because it's very hard for AI to do 100% what a human does because humans are so complicated. So it is very hard to achieve that 100% accuracy like a human, but even 90% is quite hard to make, quite hard to achieve, and it's quite a very big challenge. And how to maybe tackle this challenge is working on a good quality data set, and that is huge in size, so that we can be able to in- increase its functionality and hence increasing the accuracy of the AI system. Maybe another problem is the computing power. While designing these AI systems, they need to work on algorithms that are powerful, algorithms that can make them work efficiently. So executing these algorithms, they require high computing processing power, and that will take up higher number of processing cores or higher number of GPUs in the computer, and that also is another big challenge that I'm likely to face in my project. Now, for the solutions to these challenges, what for the challenge of the bias, as I said, I can work on a larger data set that is of good quality so that I can be able to increase the functionality of my system. Then also maybe using a debiasing strategy. For example, a debiasing strategy can be established by developing the awareness of the bias in order to reduce its impact because it greatly impacts the functionality of an AI system. So they create its awareness by establishing a debiasing strategy. Then another solution to my challenge is basically okay, the major so okay, in order all the major problems can be solved by using a larger data set that is of good quality, in order to increase the functionality of my AI system, and that will clock into a higher levels of accuracy of my system. Then also maybe for the problem of the computing processing power or something, I can use simpler. or simpler or condensed AI algorithms. In coding, we call it code refactoring, whereby we use simple short code that can execute efficiently without using high processing power or something. And that will also enable us to optimize the computing power that is available in order to come up with well functioning AI projects. Then another thing is maybe introduction of nudges. So the meaning of nudges, like this means a modification that is made to an environment in order to alter people's behavior in a predictable way without changing their instincts in a significant way. Now I want to introduce a system on road that controls ambulances in traffic. Now it can verify and identify ambulances on traffic, but now the problem is letting them through, letting them go through the traffic without being unaffected or blocked by other cars. So nudges can be used whereby we can in some way modify the environment in order to allow ambulances pass through the traffic safely without any blockages or interruptions or obstacles. So that those are the basic major solutions to my challenge that I'm likely to face in my AI project. Then also for the differences between the accuracy, there are basically three metrics we use here while building AI projects. That is the accuracy, we have the recall and the precision. So for the accuracy, this is basically the ratio of the correct predictions out of all predictions made by an algorithm. Then for the recall it is the ratio of the correctly predicted outcomes to all the predictions that are made. Then for precision is the ratio of the true positives over the sums of the false positives and the true negatives, and those are all formulas. The way I'm saying them, they are formulas. Then the F1 score. F1 score, this is a way to measure how much accuracy is present in a data set. That is the F1 score, and it is calculated by getting by okay, and its formula, it is 2 times the precision times the recall over the precision times the recall. It works with all the three metrics of developing AI projects. The F1 score, it combines them. Then the appropriate the evaluation metrics I'll use for my project uh, is one is recall. So in recall it is a classification metric that is used to measure the performance of my model. So it is also described as a way of remembering or making insights based on a past. And in recall, why it will be suitable for me is that I'll be working with a training data set. So I have to refer to the past, I have to refer to the training data set in order to make changes or in order to verify something in the new data set. Then another evaluation metric that I will choose is precision. And this is the value that gives the value of the number of times one took the correct action of all times one took the action. Or it basically focuses on the true positives and the false positives, then therefore providing a representation that may be missed via accuracy. Accuracy, I didn't choose accuracy because accuracy may miss some fields in my while making my project. It may miss most of the fields. So basically, that is a brief summary of how my AI project will work, its problems, and how I can solve those problems. So thank you for listening to me. Thank you.